All right, so it's my pleasure to welcome back Luis de Sousa to the ESIP Soil Ontology and Informatics cluster. Today is May 23rd, and without further ado, take it away, Luis.
All right. Thank you, Kate. Good afternoon, good morning, good evening to everyone here joining this session live. So this is the second presentation I give here to the ESIP soil cluster. Quite happy to be back here again. And I'm again addressing the GloSIS web ontology. So this presentation is very different from the first one. Here I'm mainly trying to talk a bit about recent developments with links. So I will be opening some web pages on the web browser. Let's see if that works, and show you briefly what is going on right now. So if you never heard of the GloSIS web ontology before, or if you don't have yet the full grasp of what it is, I will welcome you to go on YouTube and search for my presentation. I think it was last year or 2 years ago, I don't recall, here to the soil cluster, where you have a more in-depth introduction, a longer presentation about what is GloSIS and what are its goals. Okay, so what has happened, let's say the past year or so? Probably the most important thing that happened was a submission to the Semantic Web Journal, an article that is now in peer review, and that reports the whole process that transformed the initial work conducted by the Global Soil Partnership towards a soil data exchange model into a web ontology using semantic web technologies. The good thing about the Semantic Web Journal is that it is a peer review journal. And I think I already did something wrong. Just give me a moment. Let me try again if I can open correctly. Yes. Okay, so here is the web page with the submission of this article. It was submitted late last year, and it's fully open review. So you can actually download a PDF version of the paper and actually also check the reviews. So the reviews took some time to drop in, but they are quite valuable. So the reviewers went really into great depth, not only in the article, but in the ontology itself, which was actually the most important. And they identified a number of things that now need to be addressed in our reply to the reviews, but they will indeed improve the ontology, and also very important, its documentation. So it's all open. You can already consult, come here into this webpage and see in detail what is going on in the GloSIS web ontology. Yeah, and another thing that I would also like to show is that this webpage already has over 1,000 reads. So clearly there is some interest in knowing in depth what is GloSIS and how it expresses the soil ontology. Another thing that happened in parallel to this is an update to the documentation of GloSIS. So there is now a dedicated website that is automatically generated from all the metadata and all the labeling that is spread across the ontology. So the ontology is organized in several modules. And let me show here the documentation from one of these, the module for the surface feature. So where we characterize the soil surface. And here are a number of assets that are automatically generated. For instance, listing of classes, a nice, well, depends on your perspective, types of nice but messy visual representation of this segment of the ontology. You can play around, you can move classes around and see how classes are linked together, and then onwards to a few more details of the different elements of this module. So here what we are seeing basically are the properties that can be observed for the surface for the surface feature. So, and for each of the modules, you have a documentation page like this one that we hope provide a more in-depth and easier approachable way to look into the ontology. Okay, next. Throughout last year, we also worked on providing some examples on how to create and provide data that comply with this ontology. One of these prototypes is hosted at ESRIC and provides a very small segment of data from the GloSIS database, so the World Soil Information Service. And this link takes you to a nice web page that is automatically generated by this software called Virtuoso, and that provides in HTML an overview of a knowledge graph, meaning a data set that is expressed with the RDF. So this is the landing page for GloSIS, and it has some metadata explaining who is responsible for GloSIS, the institution. Here my colleague Niels Patjes, who leads this project, and then it informs that there is a data set associated with this database, and that's the SOTER database for Cuba. And we can follow this link and see that in this data set, there are a number of elements which by the URI we can guess are soil profiles. So let's click in one of those, and we can see that in this soil profile, there are several elements, meaning layers. Let's click on a layer, and we can see that there is an observation for this layer. Click on, and well, it's an observation of pH and uses a procedure based on an aqueous solution. And there is a result for this observation, which is a value of 5.2. Okay, this is something that is interesting to look into more depth. What is important here is to notice the structuring of this data as in a graph. So I can hop on from link to link. I was in the result. Now I came back to the observation. I can go back to the layer, go back to the profile, go back to the data set. So the data organized as a graph. We have also two more prototypes, one with a large data set that was derived from the Lucas project in Europe, and another from the open SRDB database. This morning this was not working, but let's try it again. And it's still not working, but in most days it is working. And you can see another example of how soil data can be expressed with RDF compliant to the GloSIS ontology. Another interesting asset that was put online recently is a vocabulary. Basically, it's an instance of a software called Cosmos, and that has been populated with the code list from GloSIS. Let me open this web page also. And the idea here is to provide, again, a human approachable overview of the code list in GloSIS. This is still a work in progress. It needs still some structuring. Let me open, for instance, the main set of code lists. These are code lists that are associated with the FAO guidelines for soil description. And let me do, for instance, here a search. I was this morning doing a search for cereals, and here our web page is showing us that this is a set of values that are accepted as crop class values, and this is to properties that, for instance, characterize again the surface of our soil. And within this this concept of cereals, we have items such as barley, maize, millet, etc., which comply to one of the particular items of the FAO guidelines for soil description. So this is a bit, as I said, work in progress. Some web pages still don't work so well, and we need a bit more organization here. But again, it's one more piece of the puzzle to make this ontology approachable. Earlier this year, ESIP within the European Joint Program on Soil ran a masterclass on data simulation, on data transformation. And out of this work, a number of small cookbooks were produced and were set online here with the help of GitHub, a tool that we were speaking earlier before we started recording. And within this set of codebooks, there are a number of interesting elements that are relevant to the use of RDF as your basis for soil data. For instance, there is a cookbook explaining how to create URIs for your data. So very briefly, the types of URIs and how you can create URIs that identify each element of your data set. Another example, for instance, here, how to create RDF with a tool called Tarkle. And briefly, so this cookbook explains how to install the tool and how to, departing from tabular data, typical of what you can get from fieldwork, and how to transform this into RDF using the GloSIS ontology. There are other options of doing the same work with user interface tools. So I think this is something worthy to explore. It takes some time to go through all these cookbooks. They are useful in many different circumstances, not only here within the scope of GloSIS. So what else? Okay, so these are these were the recent, let's say, recent infrastructures that were put in place, but there is more stuff happening out there that is relevant not only for GloSIS, but to soil ontology in general. And something that I find really interesting is how the semantic web is slowly creeping up in a number of domains. One of the relevant things happening at the moment is the agriculture information model. This is an ontology that has been developed within the Demeter project, a new funded project. And this ontology is currently under appreciation by the OGC, the Open Geospatial Consortium. And if approved, it will be the main model approved by the OGC based on semantic web technologies. And from the OGC, what we hear is that this is the beginning of a trend, and eventually most, if not all, the main models from the OGC will either be initially described with semantic web ontologies or will be made compatible with semantic web ontologies. And also within the OGC, the development of a new standard for the exchange of geospatial data called JSON-FG, as you may imagine, is based on the JSON language. This format is, to an extent, a competitor to GeoSparkle, the original standard to exchange geospatial data on the semantic web. But JSON-FG adds a section for semantic content, and again, in the spirit of linked data, using semantic web technologies. So we have here two different ways in which the OGC is indeed embracing the semantic web, and again, showing that GloSIS is probably a bit ahead of its time in this space, but making it all the more interesting, I must say. Another interesting development is the SoilWise project. This is another project funded by the European Union. We'll start later in autumn, and it's focused on creating let's say, a pan-European soil database or a soil data system in alignment or within this universe of the INSPIRE directive. And within this project, ESRIC and other partners that have been involved in GloSIS are trying to create, let's say, to improve the ontological alignment between GloSIS and existing soil ontologies such as INSPIRE itself, but also the Australian, New Zealand model and the earlier the OGC soil interchange experiment that took place in 2016. And also within this scope to work towards, let's say, a unified set of code lists for soil. So this is one of ideas of Fanny, my colleague Fanny van Egmond, having a one-stop shop for soil code lists, so that we move from this dispersion of code lists to something that is more unified and where everybody knows that they can get their code lists in the soil domain. So this is the only slide that I'm repeating from the presentation last year. And it's basically trying here to convey the message that GloSIS still needs to have some form of governance. And I see this governance being based on a body that I call the Ontology Steering Committee, a group of computer scientists and soil scientists that, let's say, curate the ontology in connection or in interchange with the general public, with the general users of this ontology. We hope that somehow this will come to fruition in the next months or in the next year. So here's some links to where you can find the ontology, and eventually if you want to contact the developing team also in Gitter, these are the main channels for contact. And I believe, that's all for today. So let me know if you have questions.
Thank you so much.
So I will stop sharing now, and I can come back. I hope this wasn't too boring or too long.
No, not at all. So I'm going to open this up for clarifying questions. And then after we've addressed those, I'll go ahead and stop the recording and we'll roll over to open discussion. So any clarifying questions? It's always exciting to see where GloSIS is going.
Hello, Luis. I have a question about the ontology, the relationship between ontology and the vocabularies you've shown, I mean the search functionality. So like the control vocabularies, are they designed for the ontology? I mean, like their values, they are the values of some properties of some classes. Is that true?
So you can think of the ontology at the structural level. Let me use that word, structural level. So the level where you actually define categories. You define what is a profile, what is a layer, what is an horizon, what is the soil surface, right? You can think that structural segment of the ontology to be somehow independent from the code list, right? For instance, if you look into the domain model from the ISO 28258 standard, which is the basis of GloSIS, it doesn't have any code lists, right? So the code lists, they serve to fill in the gaps. The code lists in GloSIS, they have three sources. The most important sources are the FAO guidelines for soil description. It's a relatively old document, it's from 2006, but it still reflects pretty much the kind of pedogenetic and, let's say, primary soil analysis that happens on the field, and to some extent also that can happen on the lab. That's one of components. The other component is a controlled vocabulary of soil physiochemical analysis procedures, and they have been gathered from a project that took place in ESRIC some 8-9 years ago, It was called the Soil Africa Profiles. It was one of the projects funded by the Bill and Melinda Gates Foundation, where some of this work took place. And what we did at ESIP was to translate that work into RDF with using this scores ontology to create a control vocabulary for that. And then the third component are the physiochemical properties themselves. And this results from work that took place in, I believe, 2017, 2018, within the Global Soil Partnership that identified, let's say, some requirements in terms of content for the global soil information system. That said, the important thing to understand here is that these controlled content are probably the most important segment of evolution of the ontology, right? And this is where it's really important that we have feedback from people like you to tell us, hey, well, I don't understand this property. Why do you have 5 different types of aluminum properties, right? Or a question that we've been having, a discussion that has been going on this week. Why is there only a pH property? Yeah, because there's only one pH, right? pH is only one thing. You have different procedures of assessing pH, but pH is only one thing. And also another thing, if you don't mind, is that these code lists, they also provide you the means to extend, so that they are the points of extension of the ontology itself, right? So you can specialize further each of these elements into things that are necessary to suit your particular data. I hope that makes sense.
Yeah, so does that mean, like, if I want to use the ontology and to integrate our data with the ontology, we still need to like refer to the control vocabularies to get more information?
So you can do it in, there are two cases, right? Either your data already conforms with the code lists in the ontology. For instance, you already use the FAO guidelines for soil description, or you are reporting soil properties that are already in the controlled vocabularies of the ontology. That's fine, you just used it directly. Or for instance, you have data that doesn't suit or doesn't fit in this controlled content in the ontology. For instance, an example that I like to give that is very common are the texture fractions. So almost every country defines texture fractions in a different way, right? So some cut it off at 2 millimeters when it's 1 millimeter, right? And then on, sometimes there are even more than 3 texture fractions. There are 5 or 6. And if you have a data set that has a particular concept of texture fraction, you redefine that particular concept. Okay. The catch here is that then you need to publish this concept, this texture fragment assessment concept on the web yourself. Okay, and that's why I was showing here these cookbooks that we created within the European Joint Program on Soil that help you, that give you some guidance on how to do that. Which, by the way, this is an activity that is necessary in INSPIRE. So INSPIRE itself defines very top level, very light code lists that each member state needs to specialize.
So
I hope that answers your question.
Yeah, that does. Yeah, thank you.
how do you distinguish between sort of a variable or a property and a method? So you were mentioning that you have 5 different aluminum extractions. And so what was the design thinking that went to separating the aluminums but not the pH?
Yes. Design thinking. I wish it was that easy. Let's say the pH was a battle I won, the aluminum was a battle that I lost.
Okay.
Yes, well, it's not that simple. The truth is, I like this example. So your first question, Kate, so how did we distinguish what is an observable property, a feature, and then the procedure? So these are the three main elements of the observations and measurement standard that then was transformed into SOSA, which is the web ontology that reflects observation and measurements. And now observations and measurements is updated into something called observations, measurements, and samples. But it's basically giving this structure to observations of natural phenomena, no matter what they are. And so this is about going back to those standards, to those ontologies, and trying to interpret that. I don't think it's that too hard to do in the soil domain. So for instance, if you talk about pH is the property, and the feature that I'm observing is probably either a soil sample or a soil specimen, a bit of soil material. Can also be the horizon itself, because I collected soil material from the horizon and I want to observe the horizon itself. And then the procedure. And the procedure are then the options that we have on the laboratory, doing it with calcium, what is the name? KCl, that's potassium chloride, something like that. My chemistry, you can see the limitations of my chemistry very fast. Very rapidly becomes obvious. So potassium chloride or aqua solution. So that's relatively well sorted out. In the case of pH is easy because pH is a very objective definition. The potential of hydroniums, right? Again, of hydrogen ions to move on to whatever they want, right? When we get to something like aluminium, it's a bit trickier. It's a bit tricky because it's true that depending on the procedure that you use, you get different compounds. So you may get more or less things, or sometimes you get aluminium plus other compounds. So that's a trickier thing. And, at some point you just move on, lose a battle, but maybe to win the war, right? So that's the kind of questions anyway. Those are probably the most difficult questions that I've been dealing with in this work, to try to sort all this out. And it's still open to improvement. And yeah, I welcome any contributions on that.
Right. Any other clarifying questions? Otherwise, I will stop the recording and we'll roll into a chat. Right.
Okay.
Thank you so much. I will post this when it comes off the,